Good evening time to you. What we got ourselves here is a Wizard built. And what's in here is the gi7b tube, which is about a $25 tube. And this is the second time this amp's been here in 5 years. And the first time it come here, it had a burned up filter board in it, which we rebuilt. And the second time it come here, somebody put their fingers in it, and once again the problem ended up being in the rectifying filter board. And we were underneath the impression that possibly it could be the plate transformer. Well, I got a new plate transformer for it and put the new plate transformer in, and the problem still persisted, so that told me that it was downline. So I put the old plate transformer back in and went in and took the high volt board all apart and figured out what was wrong with it. It had two of the bleeders had gone to a complete open, so they were dead short. Two bleeder resistors that are down in here on this board, which was bypassing half the electrolytics, which then in turn popped the other 4 electrolytics. So I replaced all 6 of the electrolytics that are on there. And then, Mr. Aaron, if you can take note that I put standoffs on it to support it and hold it in place. It was just held down by some 2-part epoxy, which I'm not a big fan of, especially when it comes to high voltage. So I put it up on some standoffs and elevated it and locked it down, then increased the length of the ground wire a little bit and got rid of all the other little parts that were in here. For some reason, somebody told him that he needed to put a 10 ohm resistor. This guy here, which is a 10 ohm 50 water, he needed to install that between the high voltage disconnect on the board and then bypass the plate choke, which didn't work out too well. So what ended up happening was it blew up the rectifier board, but also it murdered the tubes that were inside the box. Now, normally we'd be freaking out, but since these are only $7 a piece or $20 a piece or whatever tubes, these are the old ones, Mr. Aaron. These are the old bases. I took the anode head off. As you guys can see here, the anode head's unthread from the tube body. As you can see, that's the actual tube itself, and then that's the anode, or the heat dissipation portion of it, the head. The reason I went to the other heads is that these don't have holes in them for you to mount the high voltage to, like what's right down in there. So I put the old anode heads on these tubes, on the new tubes, and then let them cook for about 5 or 6 hours to outgas. And as soon as they got stable, I brought the high voltage online and we went to testing them. Now, there's a big running debate on the inner boob gargler there, if these are a good replacement for the 500Z, and the answer is yes, for the most part. The filament voltages are close. And as you can see, the plate volts are pretty close too. This is straight from Wizard. So we're sitting just below 3,000 volts on the plate, which is roughly close to what a 3500Z does. I'm not too interested in getting into the funky conversions of taking a SB220 and converting it over with these tubes in it, or any other device that has 3500Zs in it. I'm just saying that there's a big debate. So we can expect the same drive. From the outgo, I want to tell you that we're running off this 110 outlet, which is on a 15 amp breaker. And if I really get into it, this amp will do close to 1,000 bird, but it in turn pops my breaker. So we're just going to loaf 120 watts into it, which will get us about 600 bird and about 1,800 peak. And then I'm going to take the 2950 and we're going to softly loaf that into the 2-pill, which is going to get us huge peak numbers but low on the average side. because I can't drive into it hard enough to get the average numbers to come up without popping the breaker. So I just say that from the get-go. So let's get on with it. It's a 1,000 watt slug in PEP, 1,000 watt slug in average, 5 watt slug in reverse, back from the third 10,000 watt dummy load. We're going to use a 5 watt slug here, the 5 watt slug here, and then when we get onto the 2-pill, we use this bird meter in average with the 5 watt slug in reverse to represent input tune. These are also going to represent input tune. Everybody got it? Good. Okay, so let's start out with the Connex here. I'll show you drive. Audio. 220, 230 watts worth of drive. So let's engage the box. About 4 and some change in average, and we've exhausted our ability to work the peak side of things. Now, Aaron, like I said, one of these tubes is completely flat, and it still makes like 300 watts of power, but it's just way down on output emissions, and the other one doesn't even heat up anymore. It's toast. So you got a door chock and a flat tube. But these are your 2 brand new tubes that are in there. Hello, audio. Hello. Now that's in the 2x setting, you guys. And as we all know from many of the other videos that you guys have watched, between the 40 and the 60 is that hash mark. That's 1,000 watts. Hello. Hello. And even at that, because this thing's running on 110, this should really be on 220. Or at least single phase 220. The bench lights are dimming. So, with 120 watts of drive, we're seeing 600 bird-ish. And it's capable of more than that. I've taken it to the point where it shuts off. We're not going to do that on video. But we are going to bump it up with a little bit more swing wattage. And we're going to see what our output power does. So real quickly, let me disconnect the Connex. Hook up the little 2-pill. Come over here and unplug the mic for the Connex. Plug it into the 2950. Turn that on. Damp and standby. We're going to take this back down to 1x so we can show you drive. We're going to turn on the little 2-pill here. We're going to swing about 250 watts of drive into this, Aaron. And now we're going to look at the input tune into the 2-pill. The output tune passing through the box. So let's go ahead and turn on the wizard. Remember, we're in the 1,000 watt scale side, right? Barely even moving the average meter. We're going to go to the 2x positions. We're going to vary that off the scale again. Because remember, now we're going to put about 75 more watts of drive into it. So now we're going to go down to the 5x. We're just looking at the peak numbers. The average numbers, they're not coming up. I'm not even lying to anybody about that, because once I get up there, it's enough to actually trip out the 110 breaker. Okay, here we go. Hello, audio. Hello, audio. Hello. And once again, we can see our average watts are way down. Here's our input tune. Hello, audio. Hello, audio. And we'll try to swing this up. Show the average output power. Hopefully we can do this without tripping the breaker too bad. Now the lights are dimming in here pretty good. And as we come up and drive, you'll see that our peak numbers are falling off. that down. We're going to be about in the 250 watts worth of drive again. That average number is really driven by how much modulation you can put into it and how hard you drive in a component, but it is what it is. It's fixed. This thing's running real good and real solid and stable. The tubes are staying fairly cool. Right now they're at 126 degrees and dropping fast. It's really hard to get a reading accurately with this thing off any shiny surface, but about 126 degrees, but they cool off pretty quick. Mr. Aaron, that's it. Your wizard's all fixed. And I got to thinking, I'm like Mr. Volt over here. I'm worried about the little 110 outlet. So I plugged in the one that's below the bench that's on a 25 amp outlet. Everything stayed the same. The driver stayed the same. All that noise has stayed the same. So what we're going to do is we're going to start out with low drive and we're going to run this up to a max key. Now, the other problem that we had was that I noticed when I was running this just a little bit ago, I was building a bunch of wattage and then the wattage was falling off. The power supply in this amplifier is too small. The little plate transformer is getting real hot. But I know if I don't do a video where there's a bunch of big numbers up on the thing, I'm showing these huge peaks, nobody's going to believe it. They're going to tear it all up. Ah, it's a bunch of bullshit. So, there's 700, 8, 5, 6, 7, 600 bird. It's trying to swing forward, but it doesn't want to. So the plate amps are, or the plate volts are dropping way off into the nether regions over here. So about 600 bird is all we can get out of it, 600 to 800 bird. But it can't hold it. So the plate transformer is getting hotter than a firecracker. So we're going to key it about 200 bird. If we key it real low, so it keeps tripping out on us. So Aaron, my suggestion to you, brother, is to put about 220 watts of drive in this thing and call it a day. Now here we'll back that up a little bit. It's falling down to less than 1,000 volts on the plate. And it's producing about 5 and a change in average. About 600 peak. Bird, it is, or average power. It's well over 2,500 in the PEP mode. Now if I drop this down, what I mean by drop it down, so we're only peaking a couple hundred watts. You see how smoothly that runs now? Same difference. It just can't hold it. So now, if I run the drive level to where we're not oversaturating it, check this out. 800 watts bird, right? As soon as we get close to 1,000, power supply just falls off and I can't hold it. So 800 bird. Key that around 200. But oh, now if we run our mic gain up, it just falls back on its face. Just can't handle the watts. It's making great peak numbers. Setting on nice guy, here you go. Now if we go and we look, you're going to see how hot this transformer is now. It's hot. This transformer is going to be scooching hot. (170 degrees hot). So we'll go look at the core of it. (140 degrees). (168 degrees). So you can't push it that hard, is what I'm getting at, Aaron. I'll let the tubes cool off. But I thought I'd do that as a little after shot. Now we don't have to worry about the lights clicking out on us. We can easily achieve 400 or 500 bird with this box, but the power supply won't let it do it. I thought I was done with this box, but I got to thinking. So Aaron, these are the caps that were in it, and they're 400 volt, and they're 330 UF. Well, I got to thinking, what is really holding this thing back from taking off a little bit? So what we're going to do is we're going to put these 450 volt electrolytics at 470 in the same slots inside the board. And then the other thing I did, instead of having the 25K ohm resistors that were in this thing, I went to 62K. Now what that allows us to do is put less pressure on the power supply, as on the transformer. The bleeders will be higher in resistance, so that means they'll bleed off or apply less of a load to the power supply, but just by a little. So we're trying to squeak it out. The other thing I noticed is that my average and my peak and my average meters are reading way wacky. I mean, they weren't jiving with each other the way that they should in that last little section of video. So I got to thinking about it, if this thing was seeing false wattage with the modulation of me running the carrier up and down. So what we're going to do is I'm going to overhaul this rectifier board one more time. I'm going to put the little bit bigger caps in it. We're going to back up, because on the board it calls for 25K worth of resistance for the bleeders, which me, when I do my load calculations on the power circuit, that's a little high. So it's constantly putting a load on the transformer, and we're going to see if we can get away from that. We're going to back this down. The only thing that this will make a difference on, really, that you're going to notice on your side of the street, is how quickly the high voltage bleeds off. But this will put a little less pressure, but I mean, we're grasping at straws. So we're going to see if we can get this sucker to come up a little bit better and run a little bit smoother for you. So, yeah. I'm going to put these in here, put that back in that. I might have to modify my standoffs and make them a little bit taller, but that's not a big deal. Anyhow, we're going to give that a shot. So give me just a minute. Okay. So what we did, Aaron, is I modified the high volt board. I put the bigger caps in there, and as you can see, there's I'm not going to get close enough. These are almost double the size. What I did is I did a little bit of math. Okay, so I took the input voltage from the transformer, times it by 1.145, and that told me that I had 2,000 and about 700 volts on the plate. That would be post-rectified. So with those capacitors, there was 2,400 and some volts worth of capacitance. Otherwise the capacitor bank couldn't handle anything more than that. So with these are 2,700 volts on the button, which is exactly what you want. By going to the smaller or the higher resistance in the bleeder resistors, it made a huge difference. Now, sorry about the oscillating light. What's going on is the air that's coming out of the top of the tubes is blowing up here, moving my light around. So hopefully it doesn't make anybody sick. The main reason that I am back in this thing again for the third time is I didn't like how it was working on the meter. You spend a lot of your day in your life sitting here looking at these watt meters, and all of a sudden you get to be like a watt meter ninja. I'm not even joking now. You talk about, you can tell just by the way the meter's moving if something isn't reading right or not. So stop that sucker from oscillating. It's driving me nuts too. So I didn't like how it was moving, so I wanted to come back and I wanted to revisit it. Now I got my little prop set up. Everything's the same, 1000 watt, 5 watt, and then the 955 or the 2950. But we got over here the little 2-pill. Everything's the same. And then over here we got our 5 watt slug to show our input tune. Now, so I'm going to need the 100 watt slug. Got a couple of them. I'm going to need this. So we're going to run this thing out to its max dead key potential. And we're going to show you what we got going on for input power. So now, this is in 1x, that's in 1x, of course. Face value is 1000 watts, 1000 watts. So here's an 800 watt dead carrier. Like it's no problem. And the highest we can dead key is about 825 at the most. So now to get that, let me double check my input tune here. Keeping that as low as it can go. Let's come over here, and it's a 5 watt slug reading in reverse. So it's less than a half a watt. Right now we're dead keying 800. Just go ahead and unkey it, and then I'm going to show you what I got to put into this for drive airing to get that 800 watts. It's a 100 watt slug, and now it's reading forward. Go to 2x. So about 150 watts worth of dead carrier drive is what we're putting into this thing right now. Some of my items I bought today on eBay must be shipping. So if you keep your modulated drive under 150 bird, so about 300, 330 watts BEP, you'll be off to the races and running. So let's change this around. The 1000 watt in peak, put that in 5x. Where's my 5000 watt slug? Here's my 5000 watt slug. Put that in. We're going to put that on peak. So they're both in peak. This is a 5000 watt slug, and that's a 1000 watt slug in 5x. So we're going to back our drive down. Set it down here about 200 watts. So 3000 peak watts. But your average power is way down here. Hello, audio. About 350, 400 watts. Here. Double check that here with a 1000 watt slug. We're going to call it a day. Peak kits off. Hello, audio. Hello, audio. About 350. That's all she wrote, brother. Max dead key, 800 bird. You can get out of this thing, but it'll fall back on its face to about 400. And we can sit here for a half an hour and twiddly dink around with it, but we'll get the drive just right, and it'll hop right on up there to about 600. This is the other thing I really liked. Now we're keeping the plate voltage closer to 2000 instead of falling down to about 11, 12. So, airing at that, I'm going to leave this alone. I can't spend any more time with this little guy. I've got a bunch of other projects I got to get on to working to, but that's that. 2-tube, Wizard built, gi7b, upgraded for my buddy, Nice Guy. You're going to have fun with it. It's going to run real well for you. So, on to the next project, gentlemen. I'll see you. Bye.